Probability is a study of chances. The formula for probability is number of favorable outcomes upon number of possible outcomes, and probability is greater than or equals to 0, but lesser than or equals to 1. Usually it's a proper fraction. Mutually exclusive events are those that do not depend on each other. For example, throwing a dice twice. In this case, we will add the probability. However, mutually inclusive events are dependent on each other. So in this case, for example, if there is a bag containing 5 toffees and we take out one and then another without replacement, then it's mutually inclusive, and we will multiply the probabilities to find the total probability. The sample space is the table or collection of data which gives all the possible outcomes. For example, if we're throwing a dice and a coin. A dice has 6 sides, a coin has head and tail. So the possible outcomes can be written in a table. This is for the dice and head and tail. This is for the coin. So it's 1 comma head, 1 comma tail, 2 comma head, 2 comma tail, 3 comma head, 3 comma tail, 4 comma head, 4 comma tail, 5 comma head, 5 comma tail, 6 comma head, 6 comma tail. So for example, if we need the probability of obtaining a 6 and a head, it would be 1 upon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 upon 12. Or the probability of obtaining a 6 with either a head or a tail would be 1 and 2 upon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be 1 upon 6. Now we're doing a few questions from book 4. A man throws a dice and a coin. Find the probability that he will get the number 3 followed by a head. The probability of getting a number 3 on the dice is 1 upon 6, and getting a head on the coin is 1 upon 2. As both events are taking place together, so they are mutually inclusive and will be multiplied. So the result will be 1 upon 12 for part 1. For part 2, the question is an even number followed by a tail. The probability of getting an even number on the dice is 3 upon 6, as there are 3 even numbers, 2, 4 and 6. So 3 upon 6, and the probability of getting a tail on the coin is 1 upon 2. So the probability will be 1 upon 4. Next question 3 says 50 discs numbered from 1 to 50 are placed in a bowl. One disc is picked at random. Find the probability that the number on the disc is greater than 28. So as there are 22 numbers greater than 28 between 1 and 50, so the probability for part A will be 22 upon 50. That is 11 upon 25. The next part says includes the digit 3. Numbers including the digit 3 from 1 till 50 are 3, 13, 23, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39 and 43. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the probability will be 14 upon 50, that is 7 upon 25. For the third part, it says that the number should be prime. Prime numbers between 1 and 50 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 40, 41, 43 and 47. So the probability will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 upon 50, that is 3 upon 10. The fourth part says to find the probability of numbers between 1 and 50 which are divisible by 4. So it's 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44 and 48. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability will be 12 upon 50, that is 6 upon 25. Question 11. In a class of 30 students, 20 are boys and 10 are girls. So the first part is, if two students are selected at random, calculate the probability that one is a girl and one is a boy. Out of 30, there are 20 boys. So this is the probability for the first boy. And then as one boy is chosen, so 29 students remain. So 10 girls out of 29 students. Then plus, it is also possible that first a girl is picked. So 10 upon 30 into 20 boys out of the remaining 29. The answer would be 40 upon 87. Another way of doing this is that we can simply multiply the bracket by 2, since these two brackets are equal. The next part is calculate the probability that no girls are selected. In this case, one boy out of the 30 and then one more boy out of the remaining 29. In the beginning there were 20 boys, so 20 upon 30, 30 was the total. And then as one boy was selected, there were 19 more boys and 29 more children in the class. So the answer will be 38 upon 87. Part B says, if 2 of the 10 girls are selected at random, calculate the probability that both travel to school by bus. Out of the 10 girls, 6 travel to school by bus and 4 travel by car. Now we have to find the probability if both the girls selected travel to school by bus. Six travel to school by bus, so 6 upon 10 into 5 upon 9. In the beginning, there were 6 girls who traveled to school by bus out of 10. But now, as 1 has been selected, so 5 remain and 9 total remain. So this will be 1 upon 3. The second part is both travel to school by different means of transportation. This means that 1 travels by bus and 1 travels by car. So 6 upon 10 into 4 upon the remaining 9 plus 4 upon 10 into 6 upon the remaining 9, or this is also equals to 6 upon 10 into 4 upon 9 into 2, which is 8 upon 15. The last part is at least 1 travels to school by bus. The last part of that question was at least 1 travels to school by bus. So this means that either 2 travel to school by bus or 1 travels to school by bus. So the probability we found in the first part of both traveling to school by bus was 1 upon 3. And in the second part, we found the probability of 1 traveling to school by bus and 1 by car, that was 8 upon 15. Now, to find the probability of at least 1 travels to school by bus, the probabilities will be that both travel to school by bus or 1 travels to school by bus. So we will add these two probabilities to get the total result. 1 upon 3 plus 8 upon 15. Since these are mutually exclusive events, they are being added. So this will give 13 upon 15. Now question 16. Nora, Amira and Shirley are 3 contestants taking part in a chess competition. The probability that one of them wins the competition is 2 upon 3. It is also given that the probability of Nora winning the competition is 1 upon 3 and the probability of Amira winning the competition is 1 upon 8. Find the probability that none of them wins the competition. The probability of one of them winning the competition is 2 upon 3. So the probability of none of them winning the competition will be 1, that is the total probabilities, minus the probability of one of them winning the competition. So it will be 1 minus 2 upon 3. This will be 1 upon 3. That is the probability of none of them winning the competition. Now the probability of Shirley winning the competition is the next part. We have the probability of Nora winning the competition and Amira winning the competition. When we add the probabilities of Nora winning the competition, Amira winning the competition and Shirley, we would get the total probabilities of one of them winning the competition. So 1 upon 3 plus 1 upon 8, 1 upon 3, 1 upon 8 plus x, that is what we need, is equals to 2 upon 3, the probability of one of them winning the competition. So x is equals to 2 upon 3 5 upon 24. This is the answer to the second part. Now the third part says Nora or Shirley wins the competition. The probability of Nora winning the competition is 1 upon 3. And the probability of Shirley winning the competition that we found in this part was 5 upon 24. So 1 upon 3 plus 5 upon 24 is 13 upon 24. This is the probability of either Nora or Shirley winning the competition. The next question is question 18. The letters of the word elementary are written on individual cards and the cards are put in a box. A card is drawn at random from the box. If the letter on the card is an E, it will be put back into the box and a new card is then drawn at random. However, if the card drawn is not an E, the card will not be put back into the box and a second card will be drawn at random from the box. Calculate the probability that both of the cards drawn bear the letter E. Here there are 1, 2, 3 E's and total letters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of drawing an E is 3 upon 10. Now this E will be placed back into the box. So the probability of drawing another E will be again 3 upon 10. So the answer will be of the first part 9 upon 100, which is the probability of drawing 2 E's. Now the probability of drawing both cards that do not bear the letter E. So as there are 7 cards without the letter E, the probability of drawing a card without E is 7 upon 10 and another card without E will be 6 upon 9. This is because this card will not be placed back into the box. So now there are 6 letters without E and total there are 9 letters. So the answer will be 7 upon 15. Now the third part. Third part says one card bears the letter E while the other card does not bear the letter E. For this, if the first card bears the letter E, it will be 3 upon 10. This is replaced back into the box. So still there are 10 total cards and a card without E. So there will be 7 possible outcomes. So this plus if a card without E is picked first, so it would be 7 upon 10. Now 9 cards remain in the box and we have to draw an E, so 3 upon 9. The probability of this will be 133 upon 300. The next question is question 10. A bag contains 12 discs. There are 8 blue and 4 red discs. A disc is picked out at random and not replaced. A second disc is then picked out at random and not replaced. The tree diagram below shows the possible outcomes and one of their probabilities. Complete the tree diagram. So for the tree diagram, for the first pick, there are total 12 discs and 8 of them are blue. So the probability of getting a blue disc in the first pick is 8 upon 12. And of getting a red disc, it is 4 upon 12. When one disc has been picked, 11 discs remain, while in this case 7 blue discs remain, so it is 7 upon 11 and 4 upon 11. While in this case, as a blue disc has not been picked, so it's 8 upon 11 and 3 upon 11. Now the next part is expressing each of your answers as a fraction in its lowest term. calculate the probability that both discs are red. For both discs to be red, the probability is 4 upon 12 into 3 upon 11. This is equals to 1 upon 11. And the next part is at least one disc is blue. So for this part, what we can do is subtract the probability of none of the discs being blue from 1. That is 1 minus probability of both discs blue. This would be 1 minus 1 upon 11, that is equals to 10 upon 11. This is the probability of at least one disc. This is the probability of at least one disc being blue. Now the last part is a third disc is picked out at random. Calculate the probability that all three discs are red. If after getting two discs red, we take out another disc, the probability of getting a red again would be 2 upon 10. Since another red disc has been taken out from these, so 2 remain and then 1 less from 11 as total 10 remain. The probability would be 4 upon 12 into 3 upon 11 into 2 upon 10. This is equals to 1 upon 55.